Previously, I had looked at estimating implied volatility applying a bisection technique. The technique that we have here in the playlist, actually I took from the Volopta website. So this is for one aspect here. Initially looked at implied volatility of options using Goldseek, then using XLVDA, and then subsequently C++ and implemented in Xcode, so on. So in this video clip I intend running the same code, but implementing the full program as laid out by the Volopta website, and then that pulls in data, actual data from S&P 500 options prices, and outputs implied volatility. So let's download this file, and it's zipped, and then I zip, and I need to get, so we'll close this, and let's open up this just to get the ball moving, right? And okay, so let's just copy. And okay, I'm going to set this up in Visual Studio 2015. New project. Okay, so we'll give it a name. So what I'm looking for, what's important here is that it's Visual C++, and we come down to Win32. We take the first option, and Implied Volatility, S&P 500, and next, empty project, finish. Okay, so we'll just wait, pause. Okay, and then we right click, so we add a new item, and it's a C++ file. So again, implied volatility SP, let's just call it SP, add. Okay, there is no code here, but I did copy previously the code from Volopta. We paste, and it's the same code as before. Now there's a few issues. Again, we see a little bit of red appearing here, which means there's some issues. Those can be resolved just by deleting. So I'm finding that using namespace system, once we remove those, should be fine. Okay, and let's see. Okay, now there's an if stream, and if stream means you're calling up this library and we need to get data in. Okay, so let's go back to the zip and take a look at this. So I'll double click. Okay, and I'll file, save as, and we'll put into Visual Studio. We'll go to projects, and let's go to implied volatility, so it's this one. And okay, so I might just save for the moment on the desktop. So I just saved there. Okay, and close down. And I'll run the file before linking anything or incorporating a resource file into the project. I'll just run the file. Okay, and nothing will appear here because no data can be taken in. Right, so we just close that down and we come back here and just note that there is a file that needs to be drawn in, so we need to read this text file where the data is located, and then from that a set of implied volatilities will be worked out, and we're assuming that the stock price is currently 91, the time period is so probably 1/8 of a year. The risk-free rate is really low, 0.25%, and we have a value for A, which is, if you like, an initialization value for the lowest guess and the highest guess. So this is where we assume initially almost zero volatility, and B, the other guess, the higher guess, is 1000. So 10 would be equivalent to 1 would be equivalent to 100%. 10 is 1000. So this is an extraordinary high level of implied volatility. Okay, and in the previous video there's an explanation of the bisection technique. What we're doing here is figuring out how to incorporate in the resource file. So we're going to incorporate in that file. So we need to, well, first of all, let's go to our text file. We'll copy. Okay, so let's copy. Then go into projects, so documents, Visual Studio 2015, projects, Implied Volatility S&P 500, so that's the name of the project. And then we go into Implied Volatility, and here in this, where the source file is located and this file is located, we just paste in the S&P 500 option data. Okay, now let's go back to Visual Studio. We're going to add in the file existing item, and we're going to the debug, and it's here. So let's add that in. Now where is that? Again, it's documents. Let's make this a little bit bigger. It's documents, Visual Studio 2015 projects, that file, Implied Volatility 500, and then where the source file is located, we have this text file. Okay, so we've just added that, and it's there, and let's run. And of course it executed very quickly, and then nothing. So return 0 generally implies it disappears. So if we put in system, open brackets, pause, inverted commas, close the brackets, which I've done, and semicolon, and run again. Okay, so what we have here is for each of the strikes we have the price of the option, and what comes out is the implied volatility. So if we have this is the stock price and the time period and the risk-free rate and the initial guess, lower guess for volatility, the higher guess for volatility, then the option, the program runs, it pulls in what? It pulls in this data here. What's in the data? Well, you have it has 1 or 2 denoting whether it's a call or a put, and then the value of the option. So 1 for call, I presume, because we noticed it as the strike. The second column here is the strike or the exercise. As it increases, the value of the option falls, so that's consistent with a call. And then we have put data, and again similar series of strikes, and then we have, as the exercise falls, the value of the option increases, and that's consistent with a put. Okay, and then our output would be, so we said 1 for a call, this is the price of the option, and we get very high levels of implied volatility, so I think we can observe a kind of a skew. So it drops and then it goes up here at the end, and then again something similar. Do we have a skew here with the put? Looks like a skew here as well with the put. So more elevated values for the option. The 1.51, that's 151%, 74%. So that's really elevated levels, and probably so elevated, in fact, we might discount these particular values and focus from, and remember the stock price. Just have a look at the stock price for a moment. The stock price is here 91, so we're looking for exercises close to the stock price. Okay, so let's leave it there.